Hi, y'all. Welcome. Welcome, everybody. We'll get started in just a sec, in about 2 minutes, actually, not a sec. Hi, everybody. Welcome. I am just letting everyone in. Give me a second, and we'll get started. Cool. So let's jump into, okay, today is Wednesday. We are in pre-calc, and it is the 26th. Oh, not the 25th. Let me just make sure I have yeah, so it is the 26th. So make sure that, when we start our notes today is the 26th of August. Um, I'm going to start by going over what our agenda is, and then we're going to have our attendance check. And then I'll double check to see who's here and who's not. All right, so checking in attendance. We're going to be going back to our finishing the average rate of change notes. And then we're going to be starting on a new lesson, something called equivalent expressions. We're going to be doing groups today on Desmos. And yeah, so that's going to be our rundown. And then just reviewing the assignments and things that were due. So as a reminder, asynchronous number 2 was due yesterday at 11:59 p.m. If you haven't done it, I encourage you to turn it in. I did already post asynchronous number 3, but it's actually due Thursday, so tomorrow at 11:59 p.m. I just posted that if you want to get that out the way. So that's in general announcements right now, and that's our agenda. So let's jump into our attendance question so that to make sure I don't mark you absent here. All right, let's go. All right, so here's our attendance check-in question. For this check-in, go ahead and type your answer into the chat. What was your favorite childhood cartoon show? So let's see, I'm already getting some chats in there. So SpongeBob, and then, wow, a lot of SpongeBob. Avatar, Tom and Jerry, Ed and Eddie. Oh yeah, good. The Proud Family, that one's good. OG Ben. Courage the Cowardly Dog is a good one. Go ahead and continue to share there so I could double check who's here and who's not. Teletubbies, that one's cool. And Dora, Bob the Builder, Popeye, Kirby, yeah, Mickey Mouse Clubhouse. Oh yeah, Sailor Moon, yes. Yeah, I think so. You're on my attendance. Let me just double check for you, Rainy. Yes, this is your class. Doraemon, I never seen that one. So we got a lot of SpongeBob. Awesome. Oh yeah, as for me. Oh yeah. Oh yeah, yeah. So right now, just as a reminder, everybody, it is period 3. So just double check on your schedule that it is your period 3 class. So yeah, PPG. All right. And as far as for mine, when I was a kid, I'd like come home and we didn't really have much of a cable. So back in the day, I grew up in the 90s. So I'd come home and I'd watch whatever was available. I'd watch like Arthur. I did have Sailor Moon that would show in some cable. So that's how I like became a fan of Sailor Moon. Um, and let's see what else. Yeah, those were it. Mostly like Arthur and stuff like that when I was a kid. Thank you all for sharing though. Cool. Let's go ahead and transition from that check-in question. And let me also just repeat who I have absent though, because if you're here, please let us know. But this is who I got so far. So I don't have Shema. So if you're here, please let us know. Let's see, there's it. Okay, so I don't have Shema. I don't have, nope, I just got you, Kevin. I don't have KK and Shema, those are the only two I have absent. And if you're friends with KK or Shema, feel free to text them to let them know they're going to be marked absent so I could, get them in there. Cool. Thank you all for sharing. Let me go ahead and just take attendance in the phone now. Okay, cool. Let's go ahead and move on. So according to our agenda, we're going to go ahead and finish up our notes on average rate of change. So please make sure that you get your binder or your notebook, wherever it is that you're keeping your notes at, right? You're going to turn to the page where we left off. Just as a reminder, In our last class, we were measuring beats per minute when we were trying to figure out like what your heart rate was per minute. And then like I tried to use the Padlet, and I think for this class it didn't work. But in the end, we still figured out a way to find how many beats your heart was beating at per minute. And what we did there is we were actually finding an average rate, and that was just like a discussion on how we use average rates of change in the real world. Also, if you did your asynchronous assignment number 2, it showed you how to apply average rates of change, not just to the real world, but to functions and also to equations. So that's just making those connections with you. So let's go ahead and finish up those notes. So please make sure you got your notes out and ready with your pencil. And let's go ahead and finalize what is the definition of the average rate of change. So rates are basically used to describe how one quantity is changing in relation to another. So when we're doing our heart rate, we were doing beats per minute. So that's one quantity in relation to another, beats per minute. That's what a rate is. But if you have a function like I gave you in asynchronous assignment number 2, the rate of change is going to be defined as the change in the dependent variable y divided by the change in the independent variable x for any 2 points on a graph. So on that assignment, it's basically the average rate of change is your change in y, that's a change symbol, all over your change in x. And in that video, I kind of talk about how that formula is basically your slope formula. So y2 minus y1 all over x2 minus x1. This formula right here gives you the average rate whenever you have 2 points on a graph, or you create the 2 points from an equation. So that is an average rate of change formula. Let me go ahead and keep this slide on for 30 seconds, and then I'm going to move it on. All right, y'all, let me go ahead and clear my drawings so we can move on to the next part. So we're going to be ending our discussion on the average rate of change with a bit of an example so that you kind of have more, examples in your notes. So let's do an example of a function problem. First, I'd like you to copy down the problem. So this is, to be honest, it's not yet a question, it's a situation. So it's not really a problem. So let's go ahead and copy down. You don't have to copy this word for word, but basically it's a kid or a child tosses a tennis ball up into the air and then it lands into the mud. So the function that represents the movement of the ball is this right here. H of t equals negative 16t squared plus 16t plus 4. And again, so that's going to give us the ball's height in feet. So h represents height in feet. And t, the input variable right here, represents the time in seconds. So let's go ahead and copy this problem down. Let's have 30 seconds. The question I get asked a lot is, do we have to copy word for word? Just copy the parts of this word problem that are important for you to have. The function and what the H means and what the T means are important here. Okay, cool. Hopefully you have the main components of this problem down. Don't worry if you didn't write it all down, because in my next slide, I have it still up there. So I'm going to move us on to the next slide. if you take a look here, I kind of reposted the problem up here. So if you still need to get it down, it's up here. But below here, I'm going to start mapping out the strategies I need to do whenever I have like a word problem. So it's always a good strategy to make a model of the equation to give you an understanding of what's happening in this problem. So make a model means make a graph. When it hits in math, it's make a graph of the situation. An easy way, especially when we're doing distance learning, to quickly get a model is use Desmos. That's exactly what I did. I went to Desmos and I graphed that function there. And this is what I got. Go ahead and sketch that graph there in your notes. And once you have like a quick sketch, doesn't have to be perfect, I'd like you to also copy down the corresponding table to this graph. We're going to be filling out this table in a sec. We're going to be calculating what is the height of the ball at 0 seconds, 0.25 seconds, 0.5 seconds, and so forth. So go ahead and copy that down. And let's see if I start filling that table in. Okay, cool. Okay, so once you have this little graph down and this little table down, I'm going to show you how I fill out the table mathematically. So right now what we're doing for those who just joined in is we copied down this problem that's at the top of your screen right now. We're copying this down, and what I did is I am showing everyone that the best way to look at a word problem is to always make a model, and I included the Desmos screenshot of it. And then I asked everyone to go ahead and copy down this table. And what we're doing now is we're going to fill out the table. So let me know if you still have any more questions on what we're doing. Okay, cool. All right, so in order to fill out this table, you could, if you had your Desmos open, you could click on the dots there and it would give you some output values. Or you could, for example, take this 0 here, plug it into your equation for t, because at t equals 0 seconds, and you're going to get an output value. If you do the math here, it's nice because 0 times anything just gives you 0. So your output for this one is 4. So when t equals 0 seconds, the height of the ball is 4. So what that means is like in the child's hand, from the floor to the child's hand is 4 feet. So basically that's where the ball starts, 4 feet. So the child is probably like 4 foot something, but his hand where the ball's at, where it starts to move, is 4 feet. Okay. Next, we're going to go ahead and do at 0.25 seconds. At 0.25 seconds, where is the ball? Or how high is the ball? So we're going to take 0.25 and we're going to, again, plug it into our equation. And then you're going to do the math there. For this one, though, I want to point out that you have to remember your PEMDAS. So I'm circling the part that you need to do first. So if you, according to PEMDAS, remember it's parentheses, exponents, and then you could do multiplication and division and all that. So right here, a common error that students do is they do 16 times 0.25 first. But you actually have to do 0.25 squared first, like this. Then you go ahead and multiply, because if you don't do the squared first, you're going to get a completely incorrect answer. So this is all back to PEMDAS, like from Algebra 1. Now that you have this, we're going to do negative 16 times this plus this 2 once you times it, and then you're going to add 4. Once you do that math, you can double check my work, but you should get 7 as your output. So at 0.25 seconds, the ball is 7 feet high. So the little child threw the ball when it was 4 feet high, and then now the ball is 7 feet high. And it kind of makes sense if you look at the graph here. Cool. So now I modeled for you, and I apologize for the noise. My rabbit is out having some exercise time and it's making a lot of noise. But anyways, now that I've modeled for you how to do 2 of these, I'm going to go ahead and fill the rest of the table out. It's up to you if you want to go ahead and try to check the work, like, oh, if I plug in 0.5, do I get what Miss Sedano got? So don't worry about it. Right now, I just model for you how we do it, but let me go ahead and fill in the rest of the table now that you know how to do it, or you saw me modeling how to do it. So at 0.5 seconds, the ball is 8 feet high. Notice how that makes sense though, because on our table, 0.5 seconds, 8 feet high. That coordinate point is on there. At 0.75, if I were to plug in, I get 7 again. When I hit 1, after 1 second, the ball is back down to 4 feet. At 1.25 seconds, the ball is negative 1 feet. And at 1.5 seconds, what you would get is the ball is negative 8 feet. So just a quick thing about those negative heights. Obviously these right here, if we're talking about the real world, we throw these out because of course you can't have negative feet. If you look at your graph too, the ball hits the ground at about 1.207 seconds. Any time after that means your height is negative. That means it's not a real world type of answer. So basically, if we're talking about real world height, you would toss these answers out. Just as like a little side note about that. So now I'm gonna pause for questions about like the table and the graph right now. I'm also gonna pause to give you time to copy this down for about 30 seconds. So again, questions in the chat, or you could unmute yourself. All right, cool. So that was 30 seconds. I'm going to go ahead and clear all my drawings so that I can move on. So remember what we did just now, we're not doing yet average rate of change. Remember, that's what we're gonna do right now. But what I did right now is set up this problem for us. So whenever you have a word problem, it's always good to make a table. It's always good to make a little model of the situation just to help you out. But we will be doing something with this here table that we got. Let's go on to the next slide. So now comes the actual question. So here's the same table. I just pasted it here. You should already have this in your notes. Here's the question now. Now, where does the average rate come in, right? So we're going to be using this table to determine the ball's average velocity in feet per second. And it says for each 0.25 second time interval. So I kind of just like circled, underline, and highlight important parts of what I'm being asked to do. So I'm going to be using the table and I'm going to be looking for or finding the ball's average velocity. That means velocity is like speed, like an average speed of the ball once it left the child's hand. And the units of the speed is feet per second. So remember, whenever you have something per something, we're talking about a rate here. Remember when we did our heart rate? It was beats per minute. Now this, we have feet per second. So this is a rate that we're looking for right now. Okay? And what we're going to be looking for is for each 0.25 second time interval. So that means the first time interval that we're going to find the average velocity for is this one here. So I circled it. Okay, so between 0 and 0.25 seconds, I'm going to find the average velocity. Let's go ahead and write down what is the average velocity formula. It's known as total distance over total time. So once you have the velocity formula written down, you'll see it's basically going to be like change in y over change in x. It's going to be like your slope formula because the change in distance is basically the change in this over the change in time, which is the change in x. So this is how we set this up. The change in distance is going to be 7 minus 4. That's what I have at the top. 7 minus 4 feet And at the top, at the bottom here for my x, t is like my x, I'm going to have 0.25 minus 0. 0.25 minus 0 is just 0.25. I didn't bother writing down minus 0. Okay, 7 minus 4 is 3 feet. And then we're going to do 3 feet divided by 0.25 seconds. You could use a calculator for this. You know, some phones have a calculator on it. But if you do that on your calculator, you'll get that when the child first threw the ball in the first 0.25 seconds, the ball was moving at a speed of 12 feet per second. So that's how fast it was going. So that is our answer for the first 0.25 second time interval. Let me just pause here for questions on the first one that I did. We're going to do 2 more. Okay. All right, let's go ahead and move on to the next one. So the next one that we're going to do is going to be between 0.25 seconds and 0.5. So let me get rid of that circle I did up here. Let me use the eraser. And now this is the one we're focused on. Oh, still the eraser. Now this is what, whoa, okay. Now this is the next one we're focused on. So we're going to find how fast is the ball going in this interval, in this time interval. So we're going to again write my formula. It always helps to know what my formula is. Velocity, the average velocity is distance over time. And basically it's like my change in y over change in x. In this case, change in height over change in time. So that's why we have 8 minus 7 at the top. And at the bottom, we have 0.5 seconds minus 0.25 seconds. So this is the rate that we're trying to figure out. So let's do some of the math. 8 minus 7 is 1 feet. 0.5 minus 0.25 seconds is 0.25 seconds. You can use a calculator or your phone. 1 divided by 0.25, 4 feet per second. Will we have access to the slides? I did, to be honest, this one let me post that with today's. I'll post it with today's. I thought I did post it, but if I didn't, I will post it. So yeah, I'll post the slides today with maybe asynchronous number 3, the assignment. So notice that when the child threw the ball was first going 12 feet per second, so it's going really fast. But then as the ball kept going, like between 0.25 seconds and 0.5 seconds, it slowed down in speed, which makes sense because as the ball's going up, you have like air and stuff pushing against it, so it's gonna slow down. It slowed down to 4 feet per second. Now, I'm not gonna do this last one here. I want you all to try that out, but I will give you the answer. So the last one I'd like you to do in your notes is try this one out. So between 0.5 to 0.75, what is the velocity of the ball? And let me give you time to do that. Let me just erase this. And then I'm going to circle the one that you want to try on your own, which is this one. So how fast is the ball going in that time interval? I'll give you a little bit to try it out, and then I'll give you the answer. And then, by the way, if anyone needs a copy of the video as you're working on this, let me know. Just message me, and I'm happy to upload this and then send it to you as well. But I will post the slides today. All right. So for this one, I'm not going to show you the work for it, but I will show you the answer. So between 0.5 and 0.75 seconds, the ball is going negative 4 feet per second. That's the answer for that one. You're going to get a negative because when you do 7 minus 8 at the top of your fraction, 7 minus 8 is -1, and that's what's gonna make your whole answer negative. Just as a side note for when you try that out. This is gonna be your, oops, go back. So that's gonna be your answer for that one. And a question that came up in my other period was, well, why is it negative? Can it be negative? So velocity can be negative. So velocity is positive when it's going upward, right? But notice when we graphed it, this was a parabola. So that means what we're finding is the velocity as the ball is going downward. That means it's going to be a negative velocity. So that's why this one, it does make sense that the velocity is negative. Velocity can be both positive and negative, just as a clarification on that one. Cool. So let me know if anyone has any questions on this, needs me to pause or re-explain something as I clear my drawings here.
So, for example, you put 8 and 7.
Okay, I put
Should it be 8 minus 7, or does it have to be 7 minus 8?
Are we asking about the last one? This one here?
Yes.
Okay, so for that last one, yeah, so it always has to be in order. So basically it's going to be 7 minus 8 for this last one. Let me, oops, sorry, let me go back to this. Yeah, so for the last one, it has to be like, and the reason for that, the order does matter because you have to think of like the slope formula where you have y2 minus y1. It's always the second one first. And for this problem right here, 7 is after 8, so the 7 does go first. So it would be 7 minus 8 for this last one at the top. And then at the bottom, you'd have 0.75 minus 0.5. Minus 0.5. And at the top, 7 minus 8 for this last one will give you -1 feet. And at the bottom, 0.75 minus 0.5 is 0.25. So then if in your calculator on your phone you do -1 divided by 0.25, you'll get your -4 feet, which was the answer for the last one. Well, let me know if that's clear about the question you asked, because you were saying, I think you were talking about the order, right? Okay, awesome. And again, feel free to continue to ask questions. I'm happy to re-explain it. All right, cool. Let's go ahead and move on. So that basically is a conclusion of our notes on average rate of change. Again, if you did asynchronous number 2, that gave you additional practice on how to find average rates of change. Let me go ahead and clear these drawings so we can move on to our new topic. So we're tying up now average rate of change, and we're going to now move on. So just make sure you have these in your notes. And this is the activity that we're going to be doing, everybody. We're going to be first doing an independent thing right now, and then a group thing. So just be prepared for your group stuff, because I'm going to be doing breakout rooms again today. What will we be doing? We're going to be working on matching something called equivalent expressions, first independently. Then next, you're going to be grouped in a group of 4. You're going to be asked to come up with reasons and justifications as to why your group matched up in each card. It should include, like, try to include math strategies or any descriptive words that your whole group took. So example of descriptive phrases are like, we multiplied, we canceled out, we combined like terms. So and so is like, you know, you want to use whatever you actually did. And in your groups, you're going to be doing a Desmos activity. So that's the overview of what we're doing next. All right, you all ready for the independent part? So this is the part that you'll first do on your own. So what I have for you here is I have 4 separate cards. 2 of these cards match up. So you want to match these up. Match up the cards that are equivalent. How do you know? So first, I'd like you to first do this on your own for 3 minutes, because then once I break you out into your groups, you're going to share what you got with your group. Does anyone need any clarification or anything on the directions right now for these first 3 minutes? You're right now doing this independently for 3 minutes. Okay, cool. Go ahead and in your notebooks, copy down these four expressions. Try to match up the ones that are the same. All right, let's go ahead and have 3 minutes on this, and we'll be back in 3 minutes.
I wasn't put in a group.
So right now it's the independent time.
Oh,
Don't worry about it. Right now, I want you to first work on it independently, and then we'll have the groups. Don't worry about it. Sorry about that, y'all, if you're looking at the screen. All right, everybody, welcome back. So I definitely wanted to give you all a lot of time to just try these out on your own before we head off into our groups. So let me move on to the next slide. So here's the next piece of instruction. So in a second, I'll be grouping everyone. But before that, I first need you to join the Desmos that you're going to be doing in your groups. Go to student.desmos.com in a separate window and enter in this code right here. I have my phone, so what's cool about it is that I could just make sure that y'all are logging in here, and I could run the Desmos from here as I'm controlling the breakout rooms. So go ahead and join that. I'm gonna give you a bit of time to do that. Awesome, I have 2 people logged in so far, 4 people now. And we have 26 of us in here, so once we hit 26, we'll start to move on.
Do we sign in?
Yes, sign in. Great, I have about 16 of you that are in. I'm waiting on 10 more people. Code is not working, so it should be P5SAGA with a space in between. Okay, so you could see why that's not working for you. Okay, you got it. Okay, cool. All right, we have about 19 people in. We still need about 6 more people to get logged in. All right, awesome. So we're gonna go ahead and transition into our breakout. So let's say you're still having trouble getting in. Don't worry, in your breakout group, your team can help you out. Like, oh, here's the code, because everyone who's logged in can see the code. So I'm gonna go ahead and start the breakout groups, but I want to say this, that those who are logged in can already see in the first slide, there's going to be like introductions. You'll be introducing yourselves. You'll be assigning roles for how you're going to be doing the math together. Now, also just to let you know, I will be popping into some groups. Don't mind me, just continue your work as if I'm not there. I'm just interested to hear what conversations we're having, like when you all hit the sort. Okay, let me go ahead and stop sharing so I could put us into our breakout rooms. All right, you should have received a notification to join a room. To Amara and Rainy, make sure you click accept or to join the room. Amara, do you see a join a breakout room thing in your screen?
That was like the intro question, I think.
Mine's a sherbet.
Are we supposed to write everybody's ice cream things down?
What does the instructions say?
I don't know. I didn't read the instructions. I'm playing games right now.
Well, read it. It says write down each person's name in your group and their favorite ice cream.
I like.
You like what? It kind of went in and out.
Can y'all hear me?
Well, I can now.
Oh, okay.
Um, all right, next one, next one. Oh wait,
Oh,
Ted.
like the mangoñada,
Yeah, yeah.
like that ice cream.
Mm-hmm.
Oh,
That shit
that shit goes
hits. That
hard,
shit
dude.
hits, bro. That shit hits.
I just thought about that, and like with the crushed ice too.
All right, next.
Wait, so the recorder is Jaleel, right?
Yeah.
Alright.
Then Angel's the first one, the facilitator. I'm the team captain, and you're the, what is it called? Timekeeper. Oh, what y'all think the, what did y'all think the answer was for the little match thing? I thought it was 1 and 3 because 0 is times, because if you see on the third one, it says 0 times 1 is going to be 0. And then I think X is going to be the one that's left behind. So X is 1. So then that just leaves you with 1 and 4.
Team Cap. Yeah, Rainbow. Who was timekeeper?
Jonathan.
Me.
Wait, does that mean I'm recorder?
Oh, okay.
Oh, we're supposed to be doing this shit like actually whose name is closest to the A and shit. Oh, what the hell? Hello, team.
Yes, hello, I'm here.
Are y'all seeing what I'm seeing?
Yes.
We need to figure this out.
I think it was fine the way we had it in the beginning. We don't want to spend too much time on this.
Don't we have to go back at like 11:50?
Yeah, I think so. Okay, I'm just gonna, and then the ones that we said matched were. Oh, am I on mute? Oh no, okay. I'm not.
No, it's you and Cassie.
The ones that matched were 2 and 3 because anything to power 0, and then 1 and 2.
Bruh,
gameplay?
look, you're
Valorant?
gay.
Add me right now.
I
Oh,
can't.
you're gay.
That.
Is it
Loading
because
Valorant right now.
is it because you closed the battle light thing?
Yeah.
Yeah.
What if she comes in here right now?
Oh shit, you're
Oh
right.
shit.
Oh,
I should
oh.
literally Kevin. Good job, Kevin. Good job.
What did you match card number 4 with and
With
why?
two, or what was it? Hold on, let me check.
With number 1.
Yeah, number
Well,
1.
well, the other one, I just like knew anything to the power of 0 was
It's
1.
1, so I just
Yeah.
with that. Yeah, okay.
With
She came in at the 10 out of 10 time.
Bruh, how did it flip on?
Just give up, man. You only have 4 minutes left. It's okay.
I wasn't talking to you no more. I was talking about the game.
You know she recording this too, right?
Mm-hmm. Tell her to write it down too.
Okay.
All right.
What did you match number 2 with?
Damn.
And then number 7 is nothing. It just says that we're done.
Oh, okay. That's easy then.
Yeah.
Hey y'all, welcome back. I'm still waiting for a few of us into the room, the main room here. So I was popping in and out of some rooms. I saw some great stuff. I saw some groups that were quiet, and I saw some groups were working on the task independently. So in the future, I'll give some more feedback on like the expectation for group work, but I think it was okay for our first, kind of Desmos together. A good feedback I want to give is breakout room number 5. When I joined, one of them, I think it was Kevin, you were sharing your screen. That kind of helped your whole group see what you're typing and what you're doing. So as a future thing, it'd be great if somebody in the group can share the screen, and that could be a thing I could add into the Desmos too, like, hey, who's sharing your screen so that you all can view it, and so it's not confusing. So that was just like a little prop for you for breakout room number 5 when you all decided to share your screen. So great. So the answer though, what is the correct answer on the cards, right? We're going to be finding out the answer tomorrow on our Thursday class. So don't worry, just keep that in your mind. If you did not get to finish the Desmos, please finish it independently, right? If you didn't get to do it in your group, then go ahead and finish it for me so I can collect data on what your thoughts are. Just as a last thing, the asynchronous number 3 assignment is posted. It is due tomorrow at midnight. It is also a Desmos sort with follow-up questions. But we're going to be finishing up our lesson on how to match these cards up correctly tomorrow. So if you want to hold off on asynchronous number 3 until we discuss it tomorrow, feel free. And asynchronous 2 was due yesterday. Overall, everybody, great job. Thank you for your engagement. Today, we do not need to submit notes. I'll let you know when the next time we will be submitting notes as pictures. All right, y'all are free to head out. Feel free to stay if you have any questions or anything like that for me.
Wait, so what were the cards that the correct matches for the cards?
What was that?
What was the correct matches for the cards?
Okay, what were the correct matches for the cards? So we're gonna be talking about that tomorrow, but if you want like a heads up and if you want time to like figure it out, it was, let me just get the coffee out. We're gonna discuss the why tomorrow, but the correct matches is 1 and 4 and 2 and 3.
Oh, yeah. Oh, yeah.
Oh, okay, we got some of it.
All right.
Yeah. So then now your job is think about like why those are correct, but tomorrow we will be discussing it.
All right, thank you.
You're welcome. All right, y'all. Let me know if anyone has any other questions. I'll go ahead and end this meeting. Hope you all have a good day. Bye, everybody.
Bye.
Bye.